Hi, this is Dr. V.S. Dhanambal, Associate Professor in CSE Department from Kongunadu College of Engineering and Technology, Trichy. Today I am going to explain nonlinear data structure with the graph. Okay. What is the graph? The graph is a nonlinear data structure consisting of nodes and edges. The graph consists of two important positions. One is a node and another one is the edges. Okay. Node, the simple equation of graph G equal to vertices comma edges V comma E, where V is a set of vertices and E is a set of edges. The simple example graph, in this graph you have 0, 1, 2, 3, 4. These are the nodes, and edges are connected between a one node to another node. It's called as edges. In the simple example diagram, 5 vertices with the 1, 2, 3, 4, 5, 6, 7 edges. Okay, the 7 edges with the 5 vertices. Okay. The simple example definition with the simple example diagram with the vertices and edges. Okay. Then what is the purpose of edges? Means edges are used to connect it between two vertices. Vertices 1, 0 connected to the 1 using edges. Edge, then 0 to 4 connect the through the edge. Then what the important role of graph mean? The graph used in the different places. It's a simple example for graph used in the real-time applications. Information transmission in a computer network. Here you have a different computers are connected in the different locations. All the systems are connected one to another using edges. It's called as a transmission rate. It's considered as a transmission rate. Then here you have a how to you can choose or find the shortest path means using a transmission rate, edge transmission rate based on the minimum cost transfer the data from a source place to destinations. Okay, next one is a traffic flow on the highways. Is a simple another real-time example for graph. Then cities to city, it's called as a nodes. Then connected between a one city to another city using a vehicles. It's a connecting highways. Then if you are traveling from source place to destination, using find the shortest path between a one city to another city and choose the shortest path at traveling the source to destination using a graph concept. So, then application of graph, the graph are used in the different places. The graph mainly used in the real-time network transmission. Then social media network also used the graphs. These are the simple applications of graph. The next one is the types of graph. Under the types of graph, you have two important types. One is a directed graph and another one is an undirected graph. Now, what do you mean by directed graph? Directed graph is a graph which consists of directed edges where each edge in E is a undirected. Okay, it's also referred to the diagram B, W is a directed edge, then B, W is not equal to W, B. Okay, so take a simple example diagram. Here you have a three vertices A, vertices B, and another one is a vertices C. Okay, then vertices A not transfer the any direction between a vertices A to C and A to B, but C have a direction to C to A and another vertices direction is a C to B. It's also same manner in the B. We have a direction to A and B is not having a direction to the C. Okay, so it's a simple directed graph have a one vertices to another vertices have a direction path between the nodes. Okay, here the simple example C comma B, it's not equal to B comma C. Okay. Then undirected graph. What do you mean undirected graph means? The vertices, one vertices not direction path between one vertices to another vertices using edges. It's called as a undirected graph. Here A comma B, it's equal to the B comma A. Then here we discuss a lot of algorithms is there to analyze the shortest path between a source to destination. But I am going to explain to you two important algorithms under the minimum spanning tree. One is a Prim's algorithm and another is a Kruskal algorithm. These are the two important algorithms I am going to explain to you through minimum span. This belongs to minimum spanning tree. Prim's algorithm is also called as a greedy algorithm. Is used to form a minimum spanning tree for connected weighted undirected graph. Build a tree that includes every vertex and subset of edges in such a way that total weight of all edges in the tree minimized. Okay, minimized to analyze the report. Then here it's a simple algorithm for Prim's algorithm. The Prim's algorithm weighted connected graph G equal to B comma E. Weighted connected graph is nothing but each and every edges have a value. Okay, the value is called as a weighted connected graph. Then select the starting vertices. Through the starting vertices to analyze the minimum cost value, then link or create a direction between a minimum cost value with the previous cost value positions. Okay. Then here is a simple example for Prim's algorithm with the example. Here this is an example diagram. In this example diagram to analyze, it's an example graph. In this example graph used to analyze the shortest path position from a source place to destinations. Here you have a 1, 2, 3, 4, 5, 6, 7. These are the 7 vertices are called as a node. Okay. Then edges are connected between a one vertices to another vertices called as edges. It's a 1 to 6 is the edges. The edge value is 10. Then 1 to 2 edges is 28. Then 2 to 3 16. 2 to 7 14. 7 to 4 18. These are the some other edges are connected between a one vertices to another vertices. Take a simple example. Just in this overall graph, you can analyze as the shortest or minimum cost value, edge value between a one vertices to another vertices. Okay. Step 1. Here you can find only the minimum edge cost value. Here 1 to 6, 10 is the minimum edge cost value. Then insert. The next one is that you have two important possible paths. One is a 1, 6, 1, 6, and another one is a 5. But it's a 1 to 6, you have already completed that edge cost value is 10. Next one is you have possible 6 to 5 is a possible edge cost value is 25. Then 1 to 2 edge cost value is 28. 28 is possible. Now you can choose the minimum edge cost value 6 to 5 from there. That is a 6 to 5, 25. Now you have an important possible edges vertices. 1 to 2 is edge cost possible. Then also 5 to 7 is possible, and 5 to 4 is possible. Then calculated the edge cost value 1 to 2 28, 5 to 7 24, and 5 to 4 22. So you can choose the minimum cost value 22, 5 to 4 22. Then you can choose 5 to 4 vertices 5 to 4 using edge cost value is 22. Next we can find the shortest or minimum edge cost value. Then 4 to find 12. The remaining all the edge cost value is higher than the 4 to 3. So we can choose 4 to 3. The edge cost value is 12. Next you can find minimum edge cost value 3 to 2, then 16. Then finally you have completed the 2 to 7. The minimum edge cost value is 14. Is the final position from source place 1 to 7. Okay. Then how to calculate the shortest minimum cost value means 1 to 6, 10 plus 25, 25 plus 22, and 22 plus 12 from 4 to 3, 12, and 16, 14. That's calculated is a total cost edge cost value from a source to destination using a Prim's algorithm. Okay. The next one is a Kruskal algorithm. Okay. Kruskal algorithm is a simple algorithm followed by the minimum spanning tree. Okay. Step 1: sort all the edges from low weight to high weight. Take the edges with the lowest weight and use its connected the vertices of the graph. If adding an edges, create a cycle, then reject the edges and go for the next least weight edge. Step 4: keep adding edges until all the vertices connected to the minimum spanning tree. Okay. Then here, so take a same example. Just take a same example, then you can find the minimum cost value between one location to another location, otherwise one vertices to another vertices. This example diagram, the minimum edge cost value is 1 to 6 is at 10. Next we can find the minimum edge cost value is 1 to 6 already completed. Next we can find the overall, you can find only overall the graph of the overall vertices position of the graph. Previous in the Prim's algorithm, we can find 1 to 6 is the minimum cost value means 6 means, then we can find from 1 to any other position, other vertices. Otherwise, it's possible to find the 6 to any other vertices. But in this Kruskal algorithm, we can find minimum edge cost value in the overall graph. Then 1 to 6, the edge cost value is 10. Next, we can find 3 to 4, the minimum edge cost value is 12. Next, we can find 10, 12. Next one is a 14. Start from the 2 to 7, the 14 minimum edge cost value. Next, you can draw 2 to 14. Next we can 14 after we can find 2 to 3. Minimum edge cost value is 16. Then we can draw the diagram 2 to 16. This is overall you can find. Then Kruskal algorithm don't create a cycle. Without cycle, you can find the shortest path, shortest edge cost value from your source space to destinations. If you sometimes say a simple example, suppose 1 to 2, the edge cost value is 15. Means just you can draw the 1 to 2 means it's automatically create a cyclic form. Please avoid the cyclic form in the followed by Kruskal algorithm. It's a rule for the Kruskal algorithm. Okay. Then finally your destination, calculate the final position. It's used for the 1 to 6, 6 to 5, 5 to 4, 4 to 3, 3 to 2, and final answer 7. Okay, so calculate the final edge cost value 10 plus 25, 22 plus 12 plus 16 plus 4. Okay, this is the Kruskal algorithm used in minimum spanning tree. Okay. Okay, today I explained the two important concepts followed by minimum spanning tree. First, we have discussed what is non-linear data structure. It's a non-linear data structure. We have two important types, tree and graph. Already we are explained the three concepts. Now we explain the graph with the simple two algorithms. Graph, the two algorithms are very important algorithm under the graph concept. Graph is have two important positions, nodes and edges, with the equation of G equal to B comma E. Then is a lot of applications are used under the to find the shortest path using a graph concept. Then you have applications types of graph. You have two important types of graph. One is a directed graph and another one is undirected graph. Directed graph, you have a direction path have a direction path between one vertices to another vertices. Undirected graph, you have not having a direction path between one vertices to another vertices. Just you have direction between edges connectivity between one vertices to another vertices. I'm going to explain the two important concepts. One under the minimum spanning tree. One is a Prim's algorithm and another is a Kruskal algorithm. What is different between Prim's and Kruskal algorithms? In this Prim's algorithm, you can find the minimum edge cost value from the previous selected positions. But the Kruskal algorithm, you can find the minimum edge cost value from your source to destination or one vertices to another vertices, any memory locations, any locations in the graph. Okay. Then what are the important advantages in the algorithms? And these algorithms are used, Prim's algorithm and Kruskal algorithm used to find the shortest path in the network, otherwise shortest path in the source to destination traveling path. These are the small advantages or very important advantages under the minimum spanning tree concept. Today I explained the two important concepts under the graph concept. Next session we are explain some other important concepts under the graph. Okay. Thank you.